Alright, quadratic equations. We're going to solve them by factoring. A quadratic equation is a polynomial whose degree is 2. So let's talk about the zero product property and the quadratic equations. So the zero product property says if two things are multiplied together and you get 0 as your answer, then one or the other one has to equal 0. Okay? And a quadratic, my speaking is hard today. A quadratic equation is an equation containing a second degree polynomial. For example, ax squared plus bx plus c equal to 0, where a, b, and c are real numbers, and if a does not equal 0, it is in standard form. Okay, so the a, b, and c are going to be important. So why do I care about quadratics and this zero product property? Well, you may not care about it at all, but you need to care about it in this class, at least for today. And that means that once we factor something, if it equals 0 already, then we can set each factor to 0 and solve. So this says factor and solve this equation. So it's x squared plus x minus 6. So I'm going to factor this guy however you want to do it. I know I'm going to have an x and a 2 here, an x and a 3 here, and let's see, this is positive, so I know my bigger number is going to be positive. So if this times this equals 0, then this equals 0, or this equals 0. Once I set them both equal to 0, I'll solve. So I'm going to add 2 to both sides, and I get x equal to 2. Subtract 3 to both sides, and I get x is equal to minus 3. So the solutions are x equal to 2 and x equal to 3. And if you want to check your work, you can substitute that back in there, and you should get 0 equals 0. And in fact, on the graph, where they equal 0 is where you're going to have x-intercepts. So this is the point 2, 0. Remember, we got x equal to 2 as one of our answers, and x equal to negative 3 equal to one of our answers. So you could also graph the equation. My very most favorite graphing utility is desmos.com/calculator. I don't get any money from them, but the cool thing is if I were to type this into Desmos and graph it, all I have to do is click on that point and it would give me the coordinates, and same for here. Alright, so let's solve this quadratic equation by factoring. So this one's a little bit less straightforward maybe. So I have x plus 3 times x plus 5 equal to 0. So if these two equal 0, then either this equals 0 or this equals 0. And this gives me x equal to negative 3 and x equal to negative 5. Alright, so this says solve the difference of squares. So that tells me that's one of those special products. So this is a square and that's a square. So I can write this as x minus 3, x plus 3 equal to 0. So x minus 3 equals 0, or x plus 3 equal to 0. So x equals 3, or x equals minus 3. Okay, use grouping to factor and solve the quadratic equation. So you can do grouping, you can factor it. Normally you can go ahead and I did not use grouping. I just did it the regular way. But remember, you're taking an online class, so you just need to get the answer. So if I were to use the AC method or trial and error, this factors into x plus 3, 4x plus 3 equal to 0. Also, if you're a visual person, you could also throw it into Desmos and find where the intercepts are. Now, sometimes they're fractions, so you would have to kind of understand what the fraction meant as far as in the graphing, but there are many ways to solve these equations. And I'm going to give you the quadratic equation, or the quadratic formula, excuse me, soon. So either x plus 3 equals 0, or 4x plus 3 equals 0. So x equals negative 3, or 4x equals negative 3, or x equals negative 3 over 4. So if I look here, this is the graph of that equation. This is negative 3/4, so it's almost to negative 1, and this is negative 3. So that's how it's good to correlate those two, because we are going to be graphing these guys eventually. Okay, so solve this by factoring. So I always look for a GCF first, and I see I can pull an x out. I also see these are all negative, so I'm going to go ahead and pull a negative x out of all these, and I get 3x squared plus 5x plus 2 equal to 0. And that gives me 3x plus 2, x plus 1, so that's 3, 5, yep. And then, so now I have three things. So either negative x equals 0, 3x plus 2 equals 0, or x plus 1 equals 0. So I can multiply both sides by negative 1 here and get x equal to 0. 3x equals negative 2, or x equals negative 2/3, and then x equals negative 1. So if you were to graph this on desmos.com/calculator, it would give you 3 spots on the graph where you have x-intercepts. Alright, solve this guy by factoring, so let's look at him. So I always look for a GCF, and I can pull an x out. X squared plus 11x plus 10 equals 0. And this factors into, I want that, so that's x, and a 10 and a 1 equal to 0. And so either x equals 0, x plus 10 equals 0, or x plus 1 equals 0. This is x minus 10, or x equals negative 1. Alrighty. We can also solve this by the square root property. This works well when you have one thing on one side and one on the other. So this is an equation, we're not getting the principal square root. So this is just slightly different. So if you take, if you have x squared equals a constant, then if you take the square root of both sides, you have to say plus or minus, because it could have originally be a plus or a minus. We don't know that. It went away once we squared it. So we're going to isolate the x term on one side of the equal sign, everything else on the other, and then we're going to simplify. So let's look at x squared minus 8. I'm going to take the square root of both sides, and I get x is equal to plus or minus the square root of 8. And that is plus or minus the square root of 4 times the square root of 2. So x equals plus or minus 2 square root of 2. Alright. Let's do another one. So this one doesn't look like it is in that form, but we can subtract the 1 from both sides, and I get 4x squared is equal to 6, and then I'm going to divide both sides by 4, and I have x squared equals 6 over 4, which is the same thing as 3/2. And then I'm going to take the square root of both sides, and I get x is equal to plus or minus the square root of 3/2. And I just leave it like that. Alright, so now they want me to use the square root property on this one. So I'm going to divide both sides by 3 because I want all the numbers on one side. And that equals 5. And I'm going to square root both sides. And I get x minus 4 is equal to plus or minus the square root of 5. I want x on one side, everything without an x on the other. So this is x equals 4 plus or minus the square root of 5. Alright. Quadratic formula. If you have ax squared plus bx plus c, where a is the number before x squared, b is the number before x, and c is your constant, any quadratic equation can be solved using the quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over the quantity 2a, where a, b, and c are real numbers. I used to joke before we had Google or domymathhomework.com that this was so important it should be your first math tattoo. There is a quadratic formula song if you want to look it up on YouTube to help you remember the quadratic formula. You are taking an online class, so you're going to be able to have your materials in front of you, but it is something that I took a few years off teaching to when my kids were really little, and this is something that popped up in that it was in between times, and I actually used to let my students sing the quadratic formula song for me for extra credit, and it became this big production in my classroom. And that's one of the things that makes me sad about online class is that we don't get to have moments like that, but doesn't make it any less valid of education. We just have less opportunities to be silly. Alright, so we're going to make sure everything's in order. So you're going to have your squared first, your x term, and your constant next. And then we're going to write out what a, b, and c is. We're going to carefully substitute. I like to put parentheses when I substitute so don't lose any signs. And then calculate and solve. So here we go. In this equation, I know that a is 1 because x squared is the same as 1x squared. B is 5. And c is equal to 1. So x equals negative b plus or minus the square root of b squared minus 4a, a is 5. No, it's not. A is 1 and c is 1. Okay. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's minus 5 plus or minus the square root. Oh, also, if you come to office hours, I'll sing the song for you. I'll totally do that. So 5 squared is 25 minus 4 all over 2. And then let's see how I can make this. So minus 5 plus or minus square root of 21 all over 2. 21 is 3 times 7, so I can't make that any simpler. So you can just leave it like that. Some people will like to write it in 2 separate fractions, but like, why do more work than you have to? That is my motto. Alright. So this is x squared plus x plus 2. So here a is equal to 1, b is equal to 1, and c is equal to 2. I'm going to do this over here. I have a note from the past saying add more room. So when you have your lecture notes posted in your course shell, we will have more room for you to work along with me. So, but for this problem up here, x equals negative b plus or minus the square root b squared minus 4ac AC all over 2a. And that gives me negative 1 plus or minus the square root 1 minus 8 all over 2. I didn't need to make that so big. And so that gives me negative 1 plus or minus the square root of negative 7 all over 2. And x equals minus 1 plus or minus I square roots of 7 all over 2. So these are imaginary, and these will not show up on a graph. So when you graph it, it'll look like it doesn't have any it won't have any intercepts because it has two imaginary roots. All right, so let's solve this problem up here, and I apologize for that. So here a equals 9, b equals 3, and c equals negative 2. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. So that gives me negative 3 plus or minus the square root 9, and then that gives me a positive 72. Also didn't need to make that this long, all over 18, and I get negative 3 plus or minus the square root of 81 all over 18, which is negative 3 plus or minus 9 all over 18. So I have two scenarios here. I have option A, where minus 3 plus 9 equals 18, and I have scenario B, where negative 3 minus 9 equals 18. So this gives me 6 over 18, which reduces to 1/3. And this gives me negative 12 over 18, which reduces to negative 2/3. So these are your two answers. All right, so there's a part of the quadratic formula called the discriminant, okay? And sometimes you don't really want to know what the answers are, or you've been told not to solve it, but just what kinds of answers are you going to get, right? And so you're like, right, I don't know, this is my first time. So the discriminant is what's under the square root. It's it's a b squared minus 4ac. And so this tells me that if you look back to the examples we just did, it'll show you b squared minus 4ac, if it equals 0, you're just going to have one rational solution, okay? If it's b squared minus 4ac is a positive number, you're going to have two solutions. You'll either have two rational or two irrational solutions. And if b squared minus 4ac is negative, then you will have two complex solutions. So they're just wanting to know what kinds of solutions you're going to have here. So we're just use the discriminant. I still good. A is 1, B is 4, C is 4. So b squared minus 4ac is 4 squared minus 4 times 1 times 4. And so that's 16 minus 16, which is 0, so I have one solution. Here A is 8, B is 14, and C is 3. So b squared minus 4ac would be 14 squared minus 4ac and that would give me 196, and 4AC is 96, so that would give me 100. So I know I have two solutions. Here A is 3, B is minus 5, C is minus 2, so B squared minus 4AC is minus 5 squared minus 4 times A times minus 2, so that'll give me 25 plus 24, 12 times 2, yeah. So that's 49. So I know it's greater than 0, so I'm going to have two solutions. Here A is 3, B is negative 10, and C is 15. So B squared minus 4AC is negative 10 squared minus 4 times A times 15. So that's 100. Minus 180, that's negative 80, so I have two imaginary. Oh, here, let's go over this again. So B squared minus 4AC, negative 10 squared, minus 4 times 3 times 15 gives me 100 minus 180. So 100 minus 180 is negative 80. Since this is a negative number, my thing up here tells me that I have two imaginary solutions. Alright, like always, I left a live link in your PDF, so if you want to watch any more videos, this video didn't do it for you, here are the other. We did not do the length of right triangle because it's not in our curriculum, but you're welcome. If you're a little bored and you want to watch something, you can watch that as well. Oh, and we also did not do completing the square. It's neat to know, but I'm trying to reduce as much as I can the things that you have to learn and not throw, or no, I'm not reducing what you have to learn. I'm trying to throw out extra stuff and only do the stuff that you need to learn. So, hope this helps.